Hi everyone, welcome to today's class. My name is Mr. Victor, and in today's class we are going to be looking at geometry. Basically, this class will be very useful to those in Basic 2, but in whatever class you are, it will still be beneficial to you. Like we've always said, geometry studies lines, angles and shapes. Today, we are going to be analyzing the dimensions that help us to calculate for problems related to geometry. Thank you. Alright, welcome again to today's class. Like we always say, geometry is a branch of mathematics which studies lines, angles and shapes. To do this properly, you must be able to analyze the dimensions which help you to carry out calculations related to whatever shape, whether plane shapes or solid shapes in geometry. And the dimensions which we analyze usually are length, width or breadth, height or depth, radius, diameter, and we have a constant which we call pi, which helps us to solve problems related to circles. Thank you. Today, I'll start by solving problems related to plane shapes and especially regular plane shapes. Firstly, we're going to be looking at areas. In looking at areas, we're going to be looking at the areas of plane shapes. Plane shapes can be divided into two. We have polygons and circles. Polygons are plane shapes that have straight sides, while circles are plane shapes that have curved sides. In today's class, I'll be giving you the area of all polygons which we have, and I'll also be giving you the area of the circle. Firstly, let's look at the area of a square. A square only has lengths, so the area of a square is given as length times length, which basically you could say L square. Secondly, we look at the area of a rectangle. A rectangle has its opposite sides equal and parallel, so it has a length and it has a width or a breadth. So the area of a rectangle is given as length times breadth. Maybe I should do that with a diagram so that it makes it much easier. This is a square. I'll try to make it really very neat. A freehand drawing. The four sides are equal. You call this length, call this length, call this length, and call this length. So the area is given as length times length, or preferably you can say L square. This is a rectangle. You could always make freehand drawings, pardon me. This side is equal to this side is equal. You see, I had to use double lines to show the difference. The longer side is called the length, and the shorter side is called the width, or you call it the breadth. So the area will be given as length times width, like I have already said here, or area is equal to length times breadth. Okay, so in carrying out calculations related to this, you should remember that the area of a square is different from the area of a rectangle. Sometimes it's confused. This has no breadth, this has a breadth. Okay? Alright, so that takes me to the next, which is the area of a triangle. It's also a polygon. Triangle is a polygon that is bounded by three sides, sometimes three straight sides or three equal straight sides or non-equal straight sides. So this is a triangle. If there are lines on the body like this, it means that all the sides are equal, but basically it always has a height. So the area is equal to half times the base. This is the base. So you can call this the base, and this is the height. So the area is half of the base times the height. I hope you got that. This is the base of the triangle, and this is basically the height of the triangle. Not all triangles have heights, like the Scalene triangle has no height. We always calculate the area in a different way. I think maybe I should show you that. Okay, like I said, not all triangles have heights. This is a Scalene triangle, and it basically has no height. So how do we find the area? You can call this A, you can call this B, and call this C. If you're looking for the area of the triangle like this, there will be no height for it. So what do? You sum A plus B plus C and divide by 2, and you can call this S. Okay, so imagine A was equal to 4 and B was equal to 5 and C was equal to 6. S will be 4 plus 5 plus 6 all divided by 2, and then the area is going to be equal to the square root of whatever you got as S, all in bracket S minus A, bracket S minus B, bracket S minus C, and then that gives you the area of a Scalene triangle. So you can write area of the Scalene triangle. So you see, Scalene triangle is different. His area is much more different from the area of other regular triangles that we have. Okay, so looking at that, you can just play that back again and then you see what we have done. I already said you can call one side of the Scalene triangle. Usually the Scalene triangle has this on the body, that way to show you that none of the sides are equal. So this side is different, it's called A, this side is different, it's called B, and this side is different, it's called C. Do you understand? And to find the area, you just find the value of A plus B plus C and divide by 2. That gives you a value called S. Alright? And then you bring S there in a square root, and then you say S minus the value for A times S minus the value for B times S minus value for C. So you could be having something like this. A is equal to this gives you 15 over 2, which is 7.5. So you could be saying 7.5, all in bracket 7.5 minus what is A? 4. Then 7.5 minus 5, and then 7.5 minus 6, and then you have the square root of that. Okay, so with this, you'll be able to find the area of this Scalene triangle. Usually regular figures are given, real numbers are used, so it's not in every occasion that you have your answer coming out with decimal points this way, but at least this gives you an idea of the area of a Scalene triangle. I believe by the time we make more calculations, it becomes clearer to you. Okay, so that takes me to the fourth one. I'd like to drop there the area of a parallelogram. I'm trying to hurry this up because, okay, this is what a parallelogram looks like. This is a freehand drawing, so just pardon me. So this is the base, and then of course this is your height. Alright, so this is the height of the parallelogram, and it's equivalent to the same height you have here, and you can also call this also the value for your base. Exactly, the area is given as base times height, and you're done. Okay, then that takes you to the trapezium, which just looks very much like this. There's a trapezoid, and then this is a regular trapezium. Usually this and this are opposite and equal. This is parallel to this. So this is also parallel to this. This is the height and this is the height. These are opposite parallel sides. Just like this also are opposite parallel sides. So you can call this A and call this B, just like you can call this A and also call this B. Okay, so the area of a trapezium, would be equal to half the sum of the parallel heights, sum of parallel sides, multiplied by the height. So you could say this is equal to half A plus B, since they are the parallel sides. This is A and this is B, they are the parallel sides. This is A and this is B, they are the parallel sides. This is the height, this is the height. So you could say half A plus B times H. And with that, or you could say A plus B all in bracket divided by 2 times H. And with that, you'll be able to find for the area of any given trapezium. Okay, we have 2 more polygons and I'm done for today. The next 2 polygons are the kite and the rhombus. The kite is the 6th polygon and it looks like this. It's what you have for a kite. The adjacent sides this way are equal, and the lateral sides are also equal. The kite has a diagonal that flows from here to here, and it has another diagonal that flows from this vertex to this vertex. So I can call this diagonal 1 and I can call the other one diagonal 2. What's a diagonal? A diagonal is a line you draw from one vertex to another vertex, or from one corner to another corner of a shape. So you see there are 2 diagonals there. The area of the kite, is going to be equal to the first diagonal times the second diagonal divided by 2. That's quite easy, right? So you just multiply the first diagonal, the length of the first diagonal, times the length of the second diagonal and divide by 2, and that gives you the area of a kite. And the same thing happens for the rhombus. The rhombus looks very much like a kite, but the difference is that the rhombus has its 4 sides equal, just like you have in a square. This side is equal to this side, just as this side is equal to this side. The diagonals are perpendicular bisectors of each other. Okay, so diagonal 1 is a perpendicular dissector of diagonal 2. So you can call this D1 and you can also call this D2. Do you understand? Alright, looking at this side is equal to this side is equal to this side, all 4 sides are equal. Also, this side is parallel to this side, just as this side is parallel to this side. So you see the difference. There are no parallelities here. Adjacent sides are equal, lateral sides are equal. Diagonal 1 does not bisect diagonal 2, even though it does, but we are not told it's a perpendicular bisector. But it's told us here. And so the rhombus is different from the kite. Oh, sorry, this is a kite and this is a rhombus. Alright, how do we find the area? The area of a rhombus, is given just D1 times D2 divided by 2. So you see they have similar areas. The area of a kite is similar to the area of a rhombus. Do you understand that? So what we have been able to do is to talk about the areas of the various dimensions of polygons. I didn't talk about the circle today because the circle is a special type of plane shape and it's way broader than what we have here. We begin talking about the circles, we talk about so much about the circles, and that's going to be another day's class. I'll leave you with this today. I'd like you to take your time to study In our next class, we're going to start off with calculations related to this. I just gave you, preliminaries about, the basic things you should know with these polygons that are regular shapes. Once again, I hope you enjoyed the class. You could play the video all over and all over again to go through what you have learned, and then it stamps in your mind. Meanwhile, my name is Mr. Victor, and I'll be with you in another class. Thank you.